Acheni kupea
Thank you, yeah.
Mbona ametuletea mbovu hapa?
hao watu wanachi market Nyamasai.
Kwani lecturer kuzile.
Bando zinaisha.
Mama nitoke kama itasumbua tena.
Na mzee kelele.
Oye. Watu wa msitu oye.
Oya. Mwenda huko. Jamii hapa. Waje kelele ungo hizi.
Toi imetatecho.
Mwana kone.
Mzee huyo kawase muna kolanga si.
Ya buda.
Hebu nimekuwa.
Wasalie kanasa mlele kakokota.
Wala tuko. Rada.
Rada.
Kwani leka mpanga nini?
Tulia huko. Oya bundle sinaisha bana. Leka.
Oya.
I'm here, but you are very noisy. Stop the noise. Are you getting me? Can you stop the noise? Here.
Lord Mr. Barasa, you can now speak. We have muted everyone now.
Yeah, I'm here. At least now that is okay. Are you getting me? Mark clear, mic clear.
Yes, you are clear. You are now okay.
Okay, let me open the folder. Let me open the notes. Are you able to see my screen?
Yes, it's okay. The basic computer software.
Okay, so let's proceed. So, good morning, class. Today we are going to look at topic 3, which is our week 4, and today we are looking at the basic computer software. So, if you go to your LMS, you will get that the notes are already uploaded, and we also have videos that have been uploaded on the same. So kindly look at the activities in the forum and try to answer those questions. There's an assignment that you're supposed to upload. At the end of this week, there's an assignment that has been there, almost 3 questions. Try to answer them and upload your answers online. So the questions are already online. The LMS has instructions for week 4. Kindly make sure that you adhere to the timelines. The quiz, the assignment will close by 9th of 10th, 2022. So ensure that you do the assignment within this time, within that time of 7 days. If you want to do it beyond 7 days, then you won't be able to access that particular, you won't be able to access those notes. So in the previous topic, we learned about the computer system, but put emphasis on the computer hardware. It's now important for us to have an in-depth look at the other side of the computer system. That is the inside of the computer, also known as the computer software. So the topic introduces you to the programs or procedures that coordinate the computer hardware to enable the user achieve their objectives or perform a task on the computer called the computer software. So the topic has 4 sections, namely introduction to computer software, software systems, operating systems, utility software, and device driver, application software, word processor, database, spreadsheet, and presentation programming languages. So what are the learning objectives at the end of this week? At the end of this week, the learner should be able to explain computer software and the classification of computer software, explain the system software and the different softwares in that category and the application and importance in computing. The number 3, explain application software and the different software in that category, such as general purpose and special purpose. So then you also explain the ready-made software versus, of course, that is something you are going to look at. If you go to activity 1, kindly on your chat box, I'm typing a question. Kindly answer, what is computer software? The question I'm typing is, what is software? So kindly answer it. What is software? Kindly answer from, I've typed the question. Hope you can see from in the chat. Hope everyone can see. So you can answer. You can see somebody saying it's intangible parts, the intangible parts of a computer. Intangible parts are intangible parts of a computer system. Intangible parts of a computer system. I can see most of them are talking about that. Software is a set of instructions. I can see guys are attempting. You can see from your screen the way you are answering. The chat box is on the screen, so I think you can see. Good, at least everybody should attempt. That is good. Good, continue. At least I can see you have a clue of what a computer is. I can see you are really giving me the. Let them keep coming. So software is a program commercially prepared and tested in software by one or a group of programmers and system analysts to perform a special task. So software is simply a set of instructions that cause a computer to perform one or more tasks. So I can see most of you are talking about set of instruction. The set of instruction is often called a program, or it's if the set is particularly large and complex, a system, of course. So I can see you are really getting, so we can stop and move on to what we are doing here. So that is good. So thank you for sharing. So the set of instruction is often called a program, or is the set, or if the set is particularly large and complex, a system. So computer cannot do any useful work without instructions from software. Thus, a combination of software and hardware is necessary to do any computerized work. So a program must tell the computer each of a set of tasks to perform in a framework of logic. So such that the computer knows exactly what to do and when to do it. Data are raw facts and ideas that have not been processed, while information is data that has been processed so as to be useful to the user. So computer software is very key. It's just a set of instructions, of course, that give instruction, of course, to hardware, what it's supposed to do. So when the user is using that particular system, you want to issue, you normally use the hardware, click your instruction, the computer responds. If you are typing, you will see what you are typing. So it's very important that we have software. Now, computer software is classified into two major classes. So software is classified into two major. We have system software and application software. Now, looking at the system software, we have operating system and operating systems, and we have also the service programs. These are the utilities, development, and the programs that are created. Then we have the application software. We have the general or ready-made applications. Then we have special purpose, tailor-made applications. So we have application software and system software. These are the major categories of software that exist, and you can see very clearly from the diagram how it is it is clearly shown. So software can be broadly classified into system software and application software. So for example, in your phones, you have system software. We have Android operating system. That is part of system software. Those ones that you used to type and input, like the Excel sheet, the Word sheet, those are actually application software. So let us dwell into what system software is and see. So this is the first set that consists of programs that control operations of the computer and make sure that the computer works efficiently. They coordinate computer activities and optimize use of computers. They are used to control the computer and develop and run application program. Example of jobs done by the system software. Software is a program or set of instructions that causes the hardware to function in a desired way. There are four main categories of system software, and they are the operating system, the translators, assemblers, utility programs. So operating system, we have operating system even in our phones that is actually controlling the operation of our smartphones. Translators, these are used for conversions. Assemblers, these ones are used to convert low-level languages, that is assembly language, into machine code. Then we have also the utility programs, which are very important. So now let's discuss each on its own and get to see what they entail. So operating system is the first one. It will interest you to know that an operating system is a group of programs that manages all activities on the computer. So an operating system also exists in a smartphone, the ones you're using, that are actually managing all the activities of your smartphone. Like you are using now the Android operating system. There are those who are using Windows operating system, and the different versions of smartphones have different operating systems. So Android is an example of an operating system. So the software that manages the resources of a computer system and schedules its operation is called operating system. The operating system acts as an interface between the hardware and the software, and it acts as the interface between the hardware and the user programs and facilitates the execution of programs. Generally, the OS acts as an interface between the user and the hardware of the computer. So we have the computer hardware and we have the user. Now, the user normally interacts with the hardware so that he can issue instructions to the so he has to press the instructions using hardware. When you like, if you're typing on the keyboard, that's the hardware. So the instructions are sent, and you can see the display through software. So generally that OS acts as the interface between the user and the hardware. So we have the user and the hardware. Hardware has its own languages. Hardware reasons in terms of zeros and ones, but that is machine language. But the human being knows the normal numbers, the normal letters. So what helps you to interface that interface is what we call the operating system. So it is a bridge between the user and the hardware. The user interface provided by the OS can be character-based or graphical. So there are so many. It can be character user interface or graphic user interface. So the character user interface, it's operated with the keyboard only. So when you operate only with the keyboard, it's called the character user interface. But when it has a GUI, the graphical user interface, the input can be operated with a mouse and a keyboard. So if you look at the current Windows we are using, Windows 8, Windows 10, Windows 11, these are very important. And GUI, graphical user interface, is the best. Even in your phones, you're using graphical user interface. You have a touch screen and you can just open a file, click on a file, open. That's already a graphical user interface in your smartphone. So already those who are using smartphones, they already have what we call a graphical user interface. So operating systems provide a software platform on top of which other programs called application programs can run. The application programs must be written to run on top of a particular operating system. So you can see the operating system and you can see the hardware. It's clearly showing the hardware and the operating system. Then you can see the application. So the system platform, this operating system, it was developed in an early 1980 by Bill Gates, Microsoft. It is suited for personal computers, DOS. That was disk operating system, are a single user and single task operating system. Windows, it works with the DOS, disk operating system, and it supports single user and multitask system. So it requires a powerful personal computer with a minimum RAM of 8 MB, that's 8 megabytes. For early Windows, it was 3, Windows 3. So one Unix and Xnix, it is suited for multi-user and multi-task system. Then we have the Mac OS operating system. This is for Macintosh, a product of Apple, has its own operating system with a graphical user interface and the WIMP features. So it's very important to note that. Or Linux, this is operating system that really added their GUI. So they also added their GUI, and that is why they are able to. Then the question that baffles many people is there need for an operating system? To answer this question, let us tackle the section below. You see, people ask yourself, do you really need an operating system? And if you have an operating system, then it means that you can't actually use your computer, or you can't use your smartphone. So one, the need of an operating system. So the operating system is a suite of programs that takes over the operation of the computer to the extent of being able to allow a number of programs run on the computer without human intervention by an operator. So that is very important. You have to look at that aspect. So the purpose of the operating system, over many years, the increased processing speeds of the processor and its massive problem solving capability brought about the need for more sophisticated modes of operating computers. So the problems encountered on the early generations were setup time. So what we are talking about is required as each job was put onto the machine, and during which time the computer was completely idle. For example, changing tape reel on tape units, changing stationery on a printer, etc. So then there was the manual intervention. This was necessary in order to investigate error conditions and to initiate corrective action. Again, the machine will be idle when this was being done. So imbalance between the processor and the peripherals. This meant that the central processor was lying idle for long period of time during the operation of the peripheral unit. So what is required is a supercontroller to ensure that facilities are used to optimal advantage. It becomes clear that the job will only be undertaken by some form of internally stored program. So this became known as an operating system. So that's how we came up to know that the operating system is important. So kindly on your chat box, we have this question I'm posting. I'm posting this question, so kindly respond on it. Respond on it. What is the full meaning of the GUI? Can you respond? I can see graphical user interface. I can see you're getting it. You're very right. It's a graphical user interface from the chat box. I can see you have a clue of what is it. Now I can also post that question. What are the main advantages? I can see most of you've gotten what a graphical user interface is. So next, I'm posing the question: what are the advantages? What are the advantages of graphical user interface? Kindly now type the advantages of graphical user interface. What are the advantages of graphical user interface? Kindly type in the chat. I can see most of you know what GUI is. Now kindly type easy to access, the advantages of graphical user interface or GUI. Give me now the advantages. It can be operated by keyboard and mouse. Easy to handle, easy to access, simple, easy for communication. It's simple, easy to handle. Simple. Yeah, you can see you have a clue of what the advantages are. And actually, without, if you look at the tediousness of using a character user interface and using GUI has a lot of advantages. Like, for example, you have your touch screen, you can just touch the buttons and you move and you open your folders. So it's quite easy. It's user friendly. So when you say it's easy, that means it's user friendly. It's attractive. It looks good. I can see some of you are also saying that's a very good advantage. So graphical user interfaces are the in thing. And they are really helping us to, like, for example, what you are seeing on the screen already, it's a GUI. You can see the GUI that we are using at the moment. And it's very important for us to be able to know its flexibility, allows for multitasking. So these are things that actually you've gotten them very well. So I can see you have a clue. So now let's discuss the functions of an operating system. So the functions of an operating system, obviously not all operating systems carry out precisely the same task. A single programming micro will not need to perform all tasks of multi-programming, multi-user mainframe computer. So the function listed below apply to a greater or lesser extent to many computers and will be explained in more depth in subsequent unit, of course. So now we go to one is job and processor scheduling. So all operating systems must have the ability to load programs into memory and start them running. More complex operating systems have to allocate CPU time. So it's very important for when they allocate CPU time, memory, input, output, resources to different processes running concurrently. So job and processor scheduling is one of the functions of an operating system, and which you need to know. And then communication with the computer user. So the operating system accepts commands from the operator and responds to them. This is usually via the console keyboard. Apart from the operator's job loading and unloading peripherals, the operator also has the responsibility of dealing with errors missed by operating system. And in the event of operating system failure, the operator must reestablish it. So the operator can key in responses to prompt from the system, and also key in commands available in the command language. So communication, that one then creates what we call communication to the user. Then we have input and output control. Reading from and writing to various peripherals is controlled by the operating system. So for example, if you are typing and you want to see it on the screen, you are typing a number on your phone, 0735616893, that's my number. So if you are typing that, you will see it on the screen. Now that control between the typing and the display will be controlled by the operating system. And we have different types of operating system, as I said. For you, mostly in your smartphones, you're using Android. So for me, I'm using Windows 8. So that's what there are different versions of operating system. So interrupt handling is another function. This is one function of the executive. When an interrupt occurs, control of the interrupt and transfers control to the most appropriate error routine. So sources of some of the interrupts are listed below. For example, if there's an interrupt caused by power failure, this has usually the highest priority. The operating system saves vital information using the dying power supply so that it can be restarted when the power returns. We have what we call arithmetic or logic errors. When the arithmetic and logic unit detects that an error has taken place, it generates a signal that causes an interrupt. Each overflow or underflow may cause an error signal, or output may be requested to an existing device. So control is passed to executive, which initiates the appropriate error routine. So control will be returned to the program once corrective action has been taken and error messages are printed. Or in the case of a fatal error that cannot be corrected, the program will be suspended permanently. So that's very important so then for each device and its associated hardware normally takes care of parity checking. If a parity errors is detected, the executive is notified by an interrupt and so on. So it's also important that it also looks at that kind of errors. Then we have the external interrupts. These are caused by events such as the operator pressing an interrupt key in the console or caused by signals from other processes in a multi-processor machine. So provision of error correction routines. Little can be done about the errors in jobs that are the result of programming faults. Apart from providing information as to the type of fault, the operating system should be able to handle errors that occur as part of normal operating activity. However, for example, if data is lost during transfer because of late service of an interrupt, a routine should be available to recover the data by setting up the read process again. So then we have data security and management, which is another key area. So this involves these main activities: preventing illegal access or amendments to user or system files, dumping the contents of files from time in case of future loss. This file may be transferred to tape and then stored offline. So this one can also enable you to, because instead of preventing illegal access, so you have to ensure that you prevent that, and the operating system can be very handy in allowing you so that it can also allow logins and can also keep logs of those who are logging. So it keeps track of file descriptions and location. Memory management, some of or all of the computer memory will be portioned with different programs running in different partitions. The operating system, which is the OS, describes on how these partitions are organized. Even in a micro, which can only run one program at a time, a memory management is required. So the operating system, for example, will occupy a different partition from the user's program. So you can have, like, for example, the operating system. Now, if you go to operating system where we call C, the C root, the C, mostly you will get that operating system is still in partition A, which is the C. Normally in the computer, they refer to that C dot. Then we have maybe the programs now coming A, B in different partitions. Partition B has also different partitions with program B, then partition C. So you can partition up to many partitions. So what happens is that in memory, you can partition it into C, D, E, F, G in different partitions and store your data. So it means you're just splitting. And if it is full, then you can use external backing storage to make sure that you are able to store your data and you don't lose it. So now let us now focus on how operating systems operate. So operating system varies considerably in their capabilities, from relatively simple single-user microcomputer systems to sophisticated mainframe computers. The modes of operation include one. So we have the single program operation. So the OS supervises the loading and running of one program at a time and the input and output of data from and to peripheral devices. So this is called a single program operation. Then we have what we call the multiprocessing characteristics. These are the modes of operation of the various operating systems. So we have what we call the multiprocessing. So this one, in large systems, one computer system may have more than one processor, but may still share or some of the same memory. So multiprocessing, that we have more than one processor, and these processors are able to process different tasks. So it means that it can do processing, multiprocessing. It has several CPUs that can be able to process data. Right now, there's in the field of grid computing, where multiprocessing is very key, and grid computing is more of parallel computing, where computers are able to process a lot of data in a short time using the capability of the grid. That is now the multiprocessors. So this is an area where researchers are still making it better. They want to have smart, smaller, and that's why we have better phones. We had bigger phones, bigger in size, but not in features. But right now, if you look at this, we have smaller phones, very nice phones with the graphical user interface, more powerful processors. So we are really moving to another level. So multiprocessing is very important, especially when you are dealing with a lot of data. Then you are able to use this capability, this operation mode of an operating system. So then we have the multi-programming. This means that two or more programs are being run concurrently. The operating system has to allocate resources to each program, allowing each one a small amount of processor time before moving on to the next one. There are many different types of multi-programming systems. So there are many. Then we have the multi-user system. Multi-user operation allows several people to be running programs simultaneously from different workstations. This is also called time sharing system, with each user in being allocated a time slice. So that's what we call a multi-user operating system. Then we have what we call the batch. So we have what we call the batch, where there are few facilities for a multi-user interactive computing, but nevertheless, several batch jobs may be processed simultaneously in order to optimize the computer resources. Then we have the multitasking systems, which could be, for example, a single user standalone microcomputer running an operating system such as Unix operating system, or operating system version 2, or Windows 3.1, which allows programs to be running simultaneously. When the term is applied to mini or mainframe computers, it implies that the concurrent execution of two or more related tasks between which communication is possible. So put in another way, multitasking is taking place when a single job is broken down into stages called tasks, which can be simultaneously executed. So it's very important that you understand those operation modes of the operating system. It's very key. The multiprocessors, so you have to really understand. So the operating system defines the type of processing that a computer is able to perform, since it controls the allocation and use of the computer resources. There are different types of operating systems according to the number of users it can support, the number of tasks it can perform simultaneously, and the user interface. So the types of operating systems, So before we go further, maybe on your chart, can you tell us the types of operating systems you know? List the types of operating systems. I'm typing a question there. So the types of operating systems. These are the types of operating systems, you know. So can you type? Types of operating systems. So we can proceed. I think you have a clue. So I can see from the answers you have a clue. So the majority of we have interrupts from so the majority of small micro-based systems have monitors which allow single user to operate the machine in an interactive conversational mode, but normally only allows one user program to be in main storage at a process at a time, i.e. there is no multi-programming of user programs. So there are a number of well-established operating systems that that fall into the category. So apart from these operating systems specific to particular manufacturers, machines, there are some that are available on a wide range of different machines. Example is the CP/M. This is control program for microcomputers produced by Digital Research, and MS-DOS produced by Microsoft. This is the Microsoft Disk Operating System, MS-DOS, which stands for Microsoft Disk Operating System. Then we have the simple batch systems. These are systems that provide multi-programming of batch programs but have few facilities for interaction on multi-access. Many commercial computer systems in use during the 1960s and early 1970s were of this type. So they were batch, but now right now very few people are using this batch because now we have even better computers currently that people are using, which are more sophisticated. So this batch thing is first out. So we have the multi-access and time sharing systems. The majority of operating systems fall into this category, but there is a wide range of complexity in these systems. On the larger microcomputers and smaller mini computers, there are a number of operating systems that are available for use on a variety of machines produced by many different manufacturers. So these are the manufacturers: Sun, Sequent, Unisys, PEC, and even IBM. So one such operating system that is gaining popularity is Unix, which is laboratories in the US. So actually you can use it free of charge. It's not like Windows where you have to pay to get some of these rights. Real-time systems mostly they are in a critical, mostly in Kenya. They use them in factories where maybe like maybe a sugar company where we have the boiler and somebody cannot access there. We have real-time systems that are normally installed there. and the real-time operating systems are very critical, or in where there are dangerous chemicals. So you can put real-time system. So the operating system, the real-time operating system has to cater for the type of real-time being used. The three types are given here in order of increasing fast response. So a more complex multi-access time sharing system where each user has largely independent choices of system facilities, each using a different language. And then we have the commercial real-time systems in which there is essentially one job, such as handling, booking, and the multi-access user has clerical rather than programming function. This system often make use of excessive data buses. Then you have what we call the process control system. This is what I've just been talking about. A system to control the operation of a chemical factory plant. Response to change must be fast as possible, and reliability is essential. So real-time process control systems vary greatly in size. So the big systems such as the one just mentioned are at other extreme, are embedded real-time control systems. So they are actually embedded real-time control system used in microprocessor-based instruments and monitoring devices, e.g. the control system in a service station pump, petrol pump, or in a domestic washing machine. So like most of the machines we have, what we are saying, we have electronics, and they have embedded operating systems. So they are within that system, and maybe they are monitoring the temperature, they are monitoring so that in case of anything, if the temperature is above a certain point, it can communicate. If the chemical is it's supposed to move to the next level and it has been delayed, it has to communicate. So this one, they are very important when they can be monitoring, especially they are monitoring in real time what is happening, maybe in a chemical factory or in a boiler in Nzoia Sugar Company or Mumias, or maybe in the steel rolling mills, Mabati rolling mills, when they are coming up with. I remember there was a problem the other day when somebody was crushed in those mills in Thika. So these are things that should have been monitored by a real-time system to ensure that safety of people. Then translators, computers can be understood instructions only when they are written in their own language. So the machine language, therefore, a program written in any other language should be translated into machine language. The software that translates the instructions of different languages is known as translators. There are two types of translators, the compiler and interpreter. I think for those who are doing programming, the SMA students, we've met and we have defined what translators and compilers are. But now, for the sake of the others, a compiler checks the entire user written program known as the source program, and if it is error-free, produces a complete program in machine language known as object program. So normally it converts a program, the written program, into machine code. So the source program is retained for purpose of modification and corrections, and the object program is loaded into the computer for execution. If the source program contains errors, the computer produces a list of errors at the end of the execution of the program, i.e. a compiler translates the whole program before execution. So an interpreter does a similar job, but in a different style. So the interpreter translates one statement at a time, and if it is error-free, executes. So this continues until the last statement. Thus, an interpreter translates or executes the first instructions before it goes to the second, while a compiler translates the whole program before execution. So if I just go up here and ask a question, Let me just ask a question. On your chart, differentiate. Differentiate. Differentiate between compiler. Differentiate between compiler. Differentiate between compiler and interpreter. Very fast. Can you tell me the differences? The difference between compiler and interpreter. On your chart, kindly tell me the difference between a compiler and interpreter. The difference. Difference between a compiler and interpreter. Everybody? What's the difference between a compiler and interpreter? The difference between compiler and interpreter. Kindly tap in your chart. What's the difference between a compiler and an interpreter? This is a type of translators. There are two. We have a compiler and an interpreter. What's the difference between the two? Kindly give me the difference. I'm waiting. Let me type. A compiler puts information while interpreter gives details of. Then a compiler translates the entire source code. I can see. Yes. Compiler puts instructions together while interpreter. Compiler checks the entire written program while interpreter translates one statement at a time. A compiler translates information once. Yeah, I can see. Compiler is faster than interpreter. Good. I can see you have a clue of what a compiler does. A compiler and an interpreter is. I can see you have a clue of the differences. Let them keep coming. So I'm watching to see. Keep typing. Yeah, so I've seen you have a clue. So I think what you say that this one converts the entire program into machine code, but an interpreter this one translates statement one at a time, and if it is error free, and executes it line by line. So this continues until the last statement. So thus an interpreter translates and executes the first instruction before it goes to the second, while a compiler translates the whole program before execution. So those are the major difference between the compiler and interpreter is error correction is very much simpler in the case of an interpreter, as it translates the statement in stages. The compiler produces an error list of the entire program at the end. So interpreter takes more time for the execution of the program compared to the compilers, as it translates one statement at a time. So looking at that, you can see it's very clear. Then what is an assembler? An assembler is used to generate machine code from assembly language. That is the source code. So when a program is written in a language, that's what we call a given programming language like assembly. That's what we call the source code. When it's in machine code, we call it object code. So the assembly normally needs to read the text twice in order to accomplish this task. It is known as the two-pass assembler. On the first pass, the assembler generates a simple table which is stored in the random access memory. This table is used to equate each symbolic address or label with an absolute address, which is usually not the address at which the program is finally loaded for execution. On the second phase, the assembler generates the machine code for each instruction. So various assembly directives can be included within the source code. These pseudomnemonic are not translated into object code, but are recognized by the assembler during the assembly process. Their purpose is to allow the user to modify in some way the object code produced. Then we have what we call utility programs. Looking at utility programs, you will realize that they are a little different from operating systems because they are used to manage computer files, diagnose and repair computer problems, and assist in helping the computer to run more efficiently. So these are pre-written programs applied by the manufacturer for maintaining day-to-day activities of computer systems. Example is copy, sort, mailing, virus, scanning, software, etc. There are various examples of these programs, and we'll discuss a few. So we have the editors. An editor allows the user to create a text file in a form which may be easily modified. Editors are available in two forms: simple line editors, which only permit operations on a single line of text, and the full screen editors. So if you go, like, for example, on my computer here, you will get a Notepad, which can normally be used. Then there are the other types of editors, the line editors and the screen editors. So the question is, what is the difference between line editors and screen editors? Look for an answer on that. I think I'll put it on, I'll post it on the discussion forum. Okay, let me just post this on the discussion forum so that you can discuss it as the course proceeds. So I'm adding it on this one on the discussion forum. So let me just move this a bit. This guy who is drawing on the screen, who is this drawing on the screen? Kindly desist. Can see somebody has been drawing on the screen. Hold on. Is he trying to sabotage this class or what? Mark D. Mark D.
Okay, let me find out who is that guy.
Because there's somebody who is really drawing on the screen. I don't know.
Let me find out.
The problem is to stop us from. So if you come here, I've said on week 3, I'm just adding. So when you come to the notes, you will see that this particular week, I've already added the activities. So in the forum, I'm adding this particular question. I'm adding a new discussion. that you will discuss this during your own time. I'm posting a question. So I'm posting it on the forum so that you can see it is part of the question. What is the difference between line editors and screen editors? You will have to reply. So you go to the forums and you'll be able to reply on that. So I'm putting it as one of the activities. And as you learn this course on the LMS, you will be able to access. You will be able to access. Also note that we also have videos under resources that you can be able to listen to. Then we have an assignment, and the assignment is only within 7 days. So if you don't do within the 7 days or 9, you'll not be able to access the assignment. So the assignment is here, and it has some few questions. State and explain any 4 functions of operating system. Give any 5 distinguishing features between machine and assembly language. What factors will you consider when buying a computer software? So these are questions that we will deal with, but we also have videos. I think I can just play one so that maybe for those who might not know. So we are going to have videos. So for those who didn't get, you can go further and listen to these videos. So I have videos, and you will be able to also get to listen to this.
Hi, and welcome to our next series of videos. In this one, we're going to take a look at software. Now, before we get going, a quick little announcement. For those of you who are students out there watching these videos, don't forget all of these videos, this entire lesson, is free and available on my YouTube channels. If you're an educator and you'd like to get access to the PowerPoints, please be sure to check out teacherspayteachers.com. There you can find my store, Mr. Ford's Class, and you can download all of these PowerPoints for only about $5 each. So be sure to check that out. Your support allows me to continue to make these educational videos. So enough about that. Let's actually get going with what we're going to talk about, and that would be software. If you remember from the previous videos, we talked about the fact that there are 2 general components to computers. There's the hardware portion, which we've talked about ad nauseum in the previous video. This one, we're going to get nauseated over software. We're going to talk about software. And we break software down into 2 groupings. We have your system software and your application software. Your system software is the stuff that runs the computer itself. These are the ones that are working with your hardware, your operating system, your utilities. That would be an example of your system software. We're going to take a look especially at operating systems later on in this video series. Your application software is what gets stuff done for you. It's the reason why you buy a computer, because you want applications to do things, whether it's Word documents or, for example, video recording, video editing, posting. These different things require applications. In order to develop software, we have a specific thing or a certain thing called software development. And there is a great definition on Wikipedia about what software development is. Software development is the computer programming, documentation, and testing involved in creating and maintaining applications and frameworks involved in a software release lifecycle resulting in a software product. What does this mean? Okay, it's a great definition, but what does it mean? Basically, what we're looking at is a methodology on how to create software and release it. And it really has to deal with more or less project management. And you see project management be used in a whole bunch of different industries, and they might change the terms and they might change the steps, but the core of it is there. Most methodologies are going to share some combination of the following stages of software development: your requirements, your design, your implementation, your verification, and your maintenance. Again, from Wikipedia. By the way, Wikipedia is an amazing resource when it comes to technology stuff. Usually Your Uber geeks are posting stuff to Wikipedia first, as far as coming from white papers to Wikipedia. So it's a good resource as far as technology information goes. So software development life cycle, you have analyzed the problem. Is there a problem? We don't need to make anything if there's not a problem. So let's say that there's a requirement. Let's say that you are at a job place, you're at the workplace, and you have a need. Something needs to be done. There's a new procedure that nobody seems to be able to do. There's no software to do it. So this would be a problem. So you're going to analyze the problem. What is the problem? What's the need? What are people doing now? What would you like them to be able to do? Market research. You're going to go out there and find out, one, if there's anything out there that already meets those needs. If not, then let's talk about the clients who are going to use it. What do they like? What kind of technology sophistication do they have? So you're doing your market research. You're gathering requirements for a proposed business solution, design a plan or design for the software-based solution. This is where you're actually going and saying, this is the problem, this is the fix. Let's design how we're going to do this. So for example, let's say the problem is there's no word processing software, okay? It's only typewriters. But we need something computer-based to be able to replace a typewriter. So what would we want in this program? We'd want something where you could type and the words would be displayed. You'd want something where you could bold the letters. You'd want something that could outline them, underline them, italicize them, change the fonts. So you are specifying what the fix is. Then you have the implementation or the coding of the software. This is where people actually sit down and write out the code that's going to create the software, which will solve the problem. You're going to test the software. Software is buggy. It's so many moving parts that something's going to go wrong, and so you have to test the software. So it's internally tested. You run it by other developers. You run it by your project manager. You're running it around the office to see what's wrong with it. In fact, you're trying to break it in many cases, which is always fun because you get to destroy it. And the problem is if you can destroy it, there's a problem, and that's where you go, okay, this is a problem, this is a glitch, let's fix this, let's release it. Then you might have an alpha release. Alpha releases are super early. You know it's going to be buggy, you know it's going to be problems. Right before it goes to market, you might have a beta release, a beta, B-E-T-A, a beta release, which is everything should be working, but we're not completely sure. In fact, Google has a lot of their stuff constantly in beta versions. They're finally releasing some things without beta, but for a long time, a lot of stuff was beta, like Gmail was beta, Calendar was beta, but that's the beta testing. That's right before you should be getting ready to release. Then you have the gold, which is, boom, we're ready to go to market. And of course, stuff will happen. Even if you've beta tested it, once it gets out to the market, out to all of the peoples out there, something's going to go wrong, and that's where you're going to fix it. So you have deployment, you get it out there, and then the last stage, which kind of is a circular thing because it goes back, and I'll talk about that in a second, but you have the maintenance and bug fixes. People will find problems, people will find ways to break the software. You release updates, you release patches. In fact, I had already recorded all of these software videos yesterday. I found out today that the sound went out of sync. That is a bug. And so when I went to Camtasia's website, I saw that it was in fact a bug, and their fix was to record the video using another software and then putting it back into Camtasia. So that would be a bug fix that they obviously didn't see during beta testing. Now, as a course developer, as an instructional system designer, and
so I think we have the videos. You will watch them and be able to learn more. So we have the introduction, you have the computer booting process, you have the operating system, you have the types of operating system, and the application software. On the types, if I was to open this one for the type from my LMS, I think again you can see the types of operating systems, which will be explained further from the video. So it's important for you to log in. So you can come here and play again on operating system. So I'll put all these in the LMS. You can use the videos to
Taking
assist
a
you.
look now at the different types of operating systems. Before we jump into the current versions of the operating systems, I'd like to cover a little bit of history. For example, the very first operating system. A lot of folks don't know who created the very first operating system. Many people think that it came from Microsoft or Apple. In fact, the very first operating system is credited to a Dr. Gary Kildall. Dr. Gary Kildall is considered the creator of the very first operating system. Now, there's some lore, there's a story about how the very first operating system came about. And here is the story. You have to remember when this was all started, Apple Computers was a nothing company. They were nobody. They were a garage company. Nobody had ever heard of them. And all of a sudden, people are buying Apple computers. I mean, this just takes off like a wildfire. And people are buying these Apple computers, and people are bringing these Apple computers to their place of employment to do work. Now, you're IBM. You are the
So
company that's
you'll
been
be able
around
to look at
forever.
this
You're
and
the big blue. And
in your own
you're
time.
going to your office.
So I think I've just shown you what you're supposed to do. So let's continue with our notes. So differentiation between line editors and screen editors. That one I said you'll discuss in the forums. And just a reminder, the forums are here. That is the basic computer software. Under basic computer software, click on forum for week 4, and you will see all the activities, all the questions under forums. So try to respond to them and see what your fellow colleagues are also presenting. I'll also look at them and see how you're faring on. So, and then you do the assignment. Again, I just repeat, make sure that you do the assignment before on the 9th of 10. Actually, before before the holiday, that is before Mashujaa. Is it Mashujaa? It's 10th. I don't know the normal day before 10/10, 10th October. You should have done that assignment. So we have linkers and loaders. There are a new set of softwares that are used to develop computer programs in modules or subroutines. So after compilation, a computer usually needs to be linked with the necessary input-output or mathematics routines contained in a runtime library. The necessary routine is then simply added to the machine code. This process is achieved with the aid of a linker, sometimes also called a binder. McDonald, this person who is adding in things on MacD, you are the admin. Can you check for me what's happening? McDonald. Hello?
Can we restart? Can we restart the meeting?
No. If we restart, we'll have issues on logging. No, don't. Let's just continue. Let's just continue. If we restart, there'll be issues. So there are new sets of, so we've been talking about linkers. So during compilation and assembly, symbolic labels are normally used to represent address. Programs can thus be made locatable, i.e. they can be loaded anywhere in unreserved RAM. So the final stage in this process involves replacing all the symbolic address with the absolute address to be used for final execution. This is achieved with the aid of a loader. Then we have the debuggers. Debuggers provide a means of testing programs interactively during runtime. Common features.
What you can do, you can stop sharing and start sharing again.
Or maybe that could be the problem. Let me stop sharing.
But I'm removing those students who are interfering with the presentation.
Yeah, because remove them. So can I now go on?
Yes.
I share again.
Yes.
That's like, yeah, this one's at least better. So debuggers provide a means of testing programs interactively during runtime. So the common features include displaying the content of a given block of memory in hexadecimal ASCII, loading a program ready for execution, filling a given block of memory with a given data value, commencing execution with the optional breakpoints, performing hexadecimal arithmetic, setting up file control block and the command tail, disassembling a block of memory, moving a block from one location to another, reading a disk file into a memory, tracing a single stepping program execution, showing memory layout of a disk file reel, writing the contents of a given block of memory to a disk, then examining and modifying the CPU registers. So as we look at the other software, it's important to remember that there can be software that is written to solve a specific problem. Such software is called application software. So now we look at what we call application software. Application software for users to do their jobs, e.g. typing, recording, record keeping, a production of financial statements, drawing, and statistics. These programs are grouped into one. I think from the bigger picture, as we began this course, we had a very nice diagram that is showing the types of application software where you have the special purpose and the general purpose, and special purpose. So they are categorized into two. So let us start with the general purpose or ready-made software. These are developed to perform a variety of tasks, usually determined by the user. Such software can be customized by users to achieve specific, for example, the MS Office, the one that we use for typing, and that's the normal Word. So if you come here, you can, sorry, let's just continue. That these are the main, so you talk about the general purpose, like the MS Office, which is used, if you go to your smartphone, you can see MS Word, you can see Excel, you can see PowerPoint, you can see Publisher, they are there, and they are what we call the general purpose softwares that you can use, and there are application softwares that you can use to solve given problems. So, so word processing for producing document, database for storing, retrieving, and manipulating data, and the various calculations on spreadsheet. So general purpose programs are as discussed below. So we have the word processing. So like this one is a word processing. So if you have a word processing, means that like this one now is a word processing, is where you can type in. So such is, you can see it's loading. That is a word processing application. This is an MS Word, Microsoft Word. This is where you can type in, and an example of the word processing application. So this one mainly is used for, you can do deletion, you can add, you can insert, you can move, you can cut, you can paste, you can do printing of a given document. So you can see, like this one is, that's a Word document, and you can see as it tries to open the other one, but this is now MS Word. You can do the file, the home, the insert. So it's important for you to know that they exist and they are there, and they'll really help you in solving a lot of problems. So there are many styles and sizes of fonts that are available to make these documents attractive. So MS Word, WordPad. This Kevin Mutula, I think, have you noted, Mark D? Mutula, Kevin Mutula is the one doing this. Hope you have noted him. Kevin Mutula, I can see is the one moving. let me again stop sharing. Kevin, stop what you are doing. You are interfering with our class. So these are the ones that I use. Then we have what we call the spreadsheet packages, spreadsheet applications. This is spreadsheet software permits performance of almost endless variety of quantitative tasks such as budgeting, keeping track of inventory, preparing financial reports, or manipulating numbers in any fashion, such as averaging each of the 10 departmental monthly sales over six-month period. A spreadsheet contains cells. So the intersection of the rows and column make what we call a cell. That intersection of. So I can show you what a spreadsheet is. We have MS Excel, Microsoft Excel as an example. It is here. You can see it's loading. So this is an example of a spreadsheet. So once you open it, you can see let it open. So this is an example of a spreadsheet. Here you can type in numbers. So the intersection of the rows and columns form what we call a cell. So we have typed 34 here is a cell, and 78 here, 90, 78. So these are the cells where you can type in your, if it is max, you can type in, and you can be able to get the totals. So you just type like sum here, sum, then you do that, and it gives you the total. So it can give you the total. Now, this is an example of a spreadsheet. So if you go to your smartphones, also you can get this spreadsheet, and mainly it has so many functions that can help you to calculate and do a lot of calculations. So the aim is to help you now carry out calculations. So each cell contains a value keyed in by the user. Cells also contain formulas with many capabilities such as adding, multiplying, dividing, subtracting, averaging. So for example, here, you can also do the average. So you can say equals, then you do average, you use functions that are in average. Click on it, average, then you take this from here, you use a colon to there. So that's the average. So the average is 56. And using this again, it can give you the whole average for all these three. So this is, it makes calculations easier. It makes it very easier. So an outstanding feature is a spreadsheet ability to recalculate automatically. If one were preparing a budget, for example, and wanted to change a variable such as increase in salary or change in an amount of car payments, the formulas will automatically be recalculated. So you can see items and the totals. So I've just shown you what I'm saying. Then we have what we call a database. So a database contains a list of information items that are simple in form or nature. So an example is a phone book that lists a name, address, and phone numbers for each entry. So in your smartphone, you have a phone book and it has all that. So once stored in a database, information can be retrieved in several ways using reports and queries. For example, all the names listed for a given area code will be printed out and used for commercial mailing to the area. An example is MS Access or DBase or Oracle. So you look at it, and it's important that the database that is more commonly used with us is the MS Access, Microsoft Access, which is just a normal. Then we have the presentation packages. This one is used for making presentations, and you can see it is here. This is MS, this is PowerPoint, Microsoft PowerPoint. that can be used to create a presentation. So that if, for example, you're talking about like this one is now is a presentation. You can see that is a presentation. Now this is MS. Like this one is a presentation, and you can see this is a presentation I was making for somewhere, and it can show you. I was looking at the constitution and the various things, so you can see that the presentation looks very nice. And if you do a slideshow, you can see that if you begin that, you can see very clearly that is our presentation. So that is a presentation. So that's a presentation you can see, and you can. So that's a presentation package. That is MS PowerPoint or Microsoft PowerPoint, and you can add graphics, and it's very important. So an example of this is PowerPoint. Preparation of software is simplified by the use of wizards to walk the user through the creation of their presentation. Then we have what we call the desktop publishing. This software permits the user to prepare documents by using both word processing devices and graphics. So desktop publishing software uses word processing software with all its ease of entering and revising data, and the supplement it with the sophisticated visual features that stem from graphic software. So for example, one can enhance a printed message with virtually any kind of illustration, such as drawing, paintings, and photographs. Examples of desktop publishing is the Page Maker, CorelDRAW, and MS Publisher. So we have Microsoft Publisher that is also used to achieve that particular task. So multimedia applications for creating video and music. It also allows users to create image, audio, and video. Example is the real player, the media player, etc. So we have also activity management programs like the calendar and the address book. Books that they have, you have all this in your smartphone. Nowadays, most of the general purpose software is being sold as computer software suites, such as Microsoft Office, Lotus Smart Suite. These suites offer 4 or more software products packaged together at a much lower price than buying the packages separately. So then we have the custom or bespoke software packages. These are specialized software that are made for specific customer specification, rather like bespoke tailoring. The bespoke software is software that is tailor made for the client. So this one is what we say now, you are coming up with your own software. And for those who are doing SMA and maybe computer science, I think you have been able to write your own programs. I think the first program you wrote is a simple program for those doing SMA. I think you're able to write your first program on how to calculate simple interest. I think we did it. So these are what we call now special purpose. We are coming up with a program that is only tailored for a given purpose. Maybe calculating the area of a circle, doing this, just special purpose. So these are your own. So it's an exact fit with the client's requirements, eliminating many of the compromises that are built into offshore software. So these softwares can be developed to do exactly what the client requires. For example, for those who we were learning programming in our class in KUC112, that's for the SMA, they were able to make their own programs. I think so far they have made almost 10 programs on and they are running in C programming language. So there's no need to accept the compromise of off-the-shelf software applications. So bespoke software can be built on your current working method, thereby using terminology your staffs are already familiar with, thereby reducing training times. So they are developed for given purpose, e.g. payroll system, stock control system. So the developed software solutions could validate user input, thereby ensuring the data in your system is as accurate as possible and is able to produce reliable, trusted output. So bespoke software is adaptable. As your business evolves, so can your software. So building on your original investment rather than starting over from the scratch. So this means you can start by developing a bespoke software application that covers one area of your business and expand this later to cover the areas. So why not buy off the shelf? Often these are the off-the-shelf software solutions that achieve many of the requirements of individual companies. However, there will normally be areas of operations that require that company to work differently, tailoring their business to the software available rather than tailoring the software to their real business requirement. Sometimes a good compromise can be achieved where a bespoke solution is used to glue together different off-the-shelf application. However, this is never the same as having a fully bespoke software solution developed from the ground up. So, like for example, we have a very special software that we have our system that is managing the students' application, the normal one that's used, our ERP, and it is tailored towards maybe managing of the university student marks and so it's specific. So that one's just tailored towards that and managing. Windows 7 web-based application can be accessed by different types of computers such as Apple computers, tablet devices, and smartphones. So the Office-based applications can be developed using many programming languages and technologies. The database applications are usually based on Microsoft Access. This application system so that you as of the day-to-day operations of the underlying Access database. So clear user interfaces are provided that offer basic functionality. Then we have the web application. Web applications are websites that have programming functionality. A typical example could be a site for booking hotels, flights. However, it is possible to build internet-based solutions that are not for use by general public, but for use by your organization alone. This can be particularly practical if you have a sales force that are home-based, for example, or if you have staff that need to access your system from many different locations. So then now we go to programming languages. So just like computers, programming languages have also evolved, and we have 5 generations of programming languages, starting from the 1st to the 5th generation programming languages. So the first 2, which is the machine language and the assembly language, those are what we call the low-level programming languages. They are low-level because these particular programming languages are directly understood by the hardware. But starting from 3rd, 4th, and 5th generation programming languages, these are what we call the high-level programming languages. High-level because they're really not understood by the machine easily because they need to be translated, and they are closer to the human being. They are really closer to the human being, so that's why they are high level. They are closer to the user, so they are called the high-level programming languages. So here you can see we have 3 different programming languages as per this note. But what I can say is that we also have the evolution of programming languages, just the way as computers have evolved. So note this. I think I'm adding on the forum. You discuss on the forum. Let me add on the forum so that you can discuss this. On this forum, now on our forum of this particular week, let me add in. Let me add these. You discuss as a group. You discuss in this. Most of these, I can see some people have already started responding to the forum. So I'm adding in another topic, and I'm saying discuss the evolution of programming. The evolution of programming languages. From first generation to fifth generation. So kindly you will respond to this. So kindly get time and respond to this, because I'm posting it in the forum. So that's for this topic. You can discuss and see the way you guys are posting on the same, and you learn something. So you already have 1, 2, 3, 4, 5, 6 questions that you need to respond to in the forum, and you can see also the way your colleagues are responding on the forum. So it's important for you to see how people are responding to the forum. You learn something from the forum. So that one is very important. So everybody will have to respond. I can see the way guys, like for example, the difference between editors and screenshot. I can see the way people are responding. Ensure that as an individual, you are able to do this activity so that you're able to learn. So from me, I can see already people are already responding. So you log into your system and be able to respond to those questions. So you discuss it in the forum. It will be important for you to discuss those questions in the forum. So I've put it in the forum so that you discuss the evolution of programming language, starting from the first generation to the fifth generation programming languages. So at this juncture, we are looking at now the 3 types of programming language. You have the machine. Computers respond only to machine languages. This language is in terms of binary code 0 and 1. All programs will be written with these codes, which are difficult, time consuming, and leading to errors while writing the program. There is no unique standard machine language. Rather, there are many machine languages. These are machine dependent. These are referred to as the first generation languages. So assembly languages, it uses mnemonic codes rather than numeric codes, as in machine code. So we have the EX add, for example, add or A is used as a symbol for addition. So you can say add A, add B. So it requires translators to convert into machine language. Like machine language, writing program in assembly language is also time consuming. They are also machine dependent, referred to as a second generation. So we have now what we call the high level programming languages, and I tell you they are more user friendly. They use English language statements to come up with the program. You write the source code using that. They are machine independent, meaning that when you write a program in one machine, you copy to the other, it can still run. But a weakness of the first 2 generations, that is assembly and machine learning, you can't copy a program from one computer to another and still run, because they are machine dependent. So it's also important, as you discuss this, you also look at the advantages and disadvantages of each generation of programming languages. So you'll have to look at that in detail. So having said that, I think you have a lot of work within the week, and you can check yourself so that next time. So today you can ask yourself, can you now define what a computer is? Can you discuss the various types of computer system, types of software? Can you identify and differentiate between various application software? Can you describe what programming languages are? So these ones, if you can able to be answer this, then you will be ready. So go through the notes. So this week we are going through these notes. And as a reminder, I've said you go to the discussion forum and also do the activities on the discussion forum. So I'm really showing you what is on the discussion forum. Then go to the notes. And as we have said, and as a reminder, I'm happy that last week at least the number of people who attempted the quiz 3, I can just see the number. For quiz 3, we have 22,083. So it means that almost 80% are doing the quizzes. Maybe week two, let's check. It will also show the number. 2189. 2189. Then we have, let me see the first assignment. So make sure that you attempt the assignment. Now this time is a written assignment, be able to upload. Week 4 is very clear on what we're supposed to do. So log into your system and be able to do the activities as we have stated. And that will be the most important thing. Having said that, I think you have 1 hour. You can start working on your assignments and also listening to these videos. Or before you leave, maybe I'll put one. I can put one of the videos to conclude this particular session. Maybe what's an operating system? Let's listen to this and we'll conclude by that. Let's conclude this by listening to this, and at the end of this, then we can you can now move into to doing your assignments and upload them. So between now and 9th of October, you should have finished assignment on week. You could have finished assignments in week 4. If you don't have finished by 9th, then you will be locked out. So make sure that within this week, you're able to do your assignment and upload online. Thank you. Let us finish with this and we'll move.
Let's take a look in this video at some of the basics of operating systems. There's a great quote that says, if at first you don't succeed, call it version 1.0. Pretty much. The operating system is the software that controls the hardware and acts as the user interface. What I mean by this is that the operating system controls your hardware. It's going to allow you as a user to be able to interact with things like your hard drive, your audio devices, your video devices. You can adjust your brightness, your contrast, those kind of things. This is hardware information. And so the operating system gives you the ability to manipulate the hardware that's on your computer. It's going to start as soon as the PC finishes off the post. So as soon as the post process is done, the operating system is going to kick in, and that's what you're going to work with. Application programs, which we'll talk about towards the end of this series, must have an operating system in order to work. They must have an operating system in the background in order to be functional. The functions of an operating system include communicating with hardware, provide a user interface, provide a structure for access to applications, enables users to manipulate programs and data. Operating systems must also have a filing system. They must also have a way in order to kind of keep track of what they use. So when you install a program, How does the operating system keep track of it? If you want to save a file, how does the operating system keep track of it? Now, when you're dealing with computer science, this gets a little bit tricky, but for us, this is not a difficult concept because we all have to deal with file systems one way or the other. Let's say at your job, you're required to submit TPS reports or some other report. There's ways to save your information. Maybe there's filing cabinets. Maybe you have to label things a certain way. Maybe you have to put things in certain places. This is what a file system is. It's a way the computer can keep track of information, of data. The two file systems of note are the ones that we use for Windows as well as the one we use for Mac. The Windows file system had two basic flavors. We had the FAT system and the NTFS. The FAT system, FAT, is the older system. This is what we found in Windows 95, Windows 98, Windows ME. It's an older version. In fact, the last version of FAT was FAT32. It was used primarily for home computers. The corporate world didn't really use FAT. It had NTFS, which we'll talk about in just a second. What's kind of cool, what's kind of geeky is you can still run into the FAT system if you have an Xbox. Case in point, I had to get extra storage for my Xbox. And so I had a removable hard drive. I'm like, oh, let me just plug it in USB. We should be good to go. And the USB external hard drive was a terabyte hard drive. I'm like, I'll never run out of space. But it couldn't see it. It wouldn't see the whole terabyte. It only saw a portion of that. And I was like, why is it not seeing the whole hard drive? So I consulted the great power of Google and found out that the Xbox still uses a FAT system. What this means is that
So you'll be able to look at those videos and be able to get more information. So, but our main diagram, this one shows software and how the classifications should be in your mind. It should be printed in your mind. And so you keep doing the assignments. Have a good week ahead. I think you have 1 hour to try and start your assignments. Have a good day, guys. Have a good week. Bye. Bye. Bye, guys. Have a good week.